I've got a couple more examples for you, sticking to the form 0 over 0 or positive or negative infinity over infinity. So in this case, as x approaches infinity, natural log of x does approach infinity. The graph of y equals natural log of x looks like this. It's an increasing function. It never completely flattens out. So as x approaches infinity, your value of natural log of x is also creeping towards infinity. It is increasing without bound. And then the x, of course, in the denominator there is increasing without bound. So this limit has the form infinity over infinity, which means L'Hopital's rule is applicable. So this limit above is equal to the limit as x approaches infinity of. Now you differentiate the numerator and the denominator independently. So the derivative of the numerator is 1 over x. The derivative of just x is 1. And now this limit has the form 1 over infinity. So finite number over infinity, this is approaching 0. So the limit in this case is 0. All right, now I've got another example for you. It's going to get quite a bit more complicated. Okay, so the limit as x approaches infinity of this numerator is 2e to the 3x plus natural log of x. The denominator is e to the 3x plus x squared. Oops, I've got to learn to mute my phone during these videos. This limit still has that form infinity over infinity. The numerator and denominator are both increasing without bound. So we can apply L'Hopital's rule. So this is equal to the limit of, derivative of the top will be 2 times the derivative of e to the 3x, which is e to the 3x, times the derivative of the inside, we're using chain rule here, derivative of the exponent, which is 3, plus the derivative of natural log of x, which is 1 over x. Now to differentiate the denominator here. So the derivative of e to the 3x is e to the 3x, again using chain rule, times the derivative of the inside is 3, plus the derivative of x squared is 2x. And so just cleaning this up, so on this step we used L'Hopital's rule. Now on this step I'm just going to use algebra to simplify this a bit. So the 2 times 3, this is 6 e to the 3x plus 1 over x over 3 e to the 3x plus 2x. Which this limit still has the form, so as x approaches infinity, we have e to the infinity, that's growing without bound, plus 1 over infinity, which is 0. But so you've got a really large number plus something close to 0, so this numerator is approaching infinity. And then denominator, 3 times e to the infinity, so that's getting really, really big, plus 2x is getting really, really big, so this has the form infinity over infinity. Which means we can apply L'Hopital's rule again. And this is equal to the limit as x approaches infinity of 6 times e to the 3x times the derivative of the inside is 3. So that's going to give us 18 e to the 3x. The derivative of 1 over x right here. Well, so if we bear in mind that 1 over x could be written in the form x to the negative 1, then the derivative of x to the negative 1, I'm seeing how clear that is for you guys, derivative of that will be negative x to the negative 2. Now in the denominator we have 3 times e to the 3x times 3, when you do times the derivative of the inside, so that'll be 9 e to the 3x plus 2. This x to the negative 2 right here can be written as 1 over x squared. As x approaches infinity, that's approaching 0. So we've got infinity minus 0, so numerator is approaching infinity, over infinity plus 2, so denominator is approaching infinity. So it's still in this indeterminate form, infinity over infinity, So we can use L'Hopital's rule again. This is going to be the last time. Let's see. So if we take the derivative of the numerator, 18 e to the 3x times 3, well, that would give us 30 and 24, so 54 e to the 3x minus the derivative of x to the negative 2. So the negative 2 will come down. This will be plus 2x to the negative 3. Derivative of the bottom will be 9 e to the 3x times 3. So that'll be 27 e to the 3x plus 0. How well can you see that? Okay. You can see it all right. This is a work in progress. I may adjust how I create these videos. I may have guest appearances with the kids and the dog. We'll see. But anyway, okay, so we've got this form. Let me copy that right here. It's just like in class, how I run myself into the side of my page of notes that I'm writing on the document camera. Let's see. I'm just going to rewrite what I had down below here. 27 e to the 3x. And there are no retakes. I'm not a video editor or anything. Anyway, okay, back to the problem at hand. When we've got just one term in the denominator like this, I could divide this into like two separate fractions. I can break this apart. So this is the limit as x approaches infinity of 54 e to the 3x over 27 e to the 3x plus 2x to the negative 3 over 27 e to the 3x. So over here, the e to the 3x's, let's bring in some red. The e to the 3x's will cancel. 34 divided by 27, that's 2. So this is 2. X to the negative 3, so I'm going to move that downstairs. So I've got 27 e to the 3x, and then I'm going to move that down, so that's x cubed. So the limit of a constant is just that constant. So the limit of the 2 right here is just 2. Over here, this is increasing without bound. This is going to infinity. X cubed, that's going to infinity. So this limit over here has the form 2 over infinity, which means it's approaching 0. And so with all of that, our answer here is 2.